Hello. In this lesson, we'll conduct a brief review of chemistry. And you will recall that chemistry is based very much on a periodic table of our elements, which looks like this. You may want to have a periodic table for reference as we go through this lesson, and it will become very important as we go through the chemistry section of your textbook. You'll recall that elements are made up of small particles called atoms. Let's take a look at what comprises an atom. Atoms are made up of protons, neutrons, and electrons. Protons have a mass of 1, or 1 atomic mass unit. Neutrons also have a mass of 1, and the mass of the electrons is typically insignificant. Protons also have a charge, a positive charge. Neutrons are neutral or have no charge, and electrons have a negative charge. So we will signify this by just saying negative. All right? Now, you will also remember that the model of an atom indicates that the protons and neutrons are located in the center, or the nucleus, of the atom. And the electrons will orbit around the outside. Now, you'll also recall that the electrons orbit that nucleus in varying orbitals or energy levels in an electron cloud. We can signify this with a dashed line around the nucleus, which houses the protons and neutrons, and we will signify the number of electrons in that orbital with just an E-, like that. Now, the first level or orbital of electrons is completely full when it contains 2 electrons. The next outer shell of electrons can hold up to 8 electrons, which will become important in a moment. But first, let's go back to the periodic table. On the periodic table, in each box, there is a symbol of 2 letters, 1 or 2 letters, which represents that particular element. For example, the very first box looks like this for hydrogen. It has the letter H. Its chemical symbol is H. But there's also additional information in each of the boxes on that periodic table. There's usually a large number in the upper part of the box, which represents the atomic number for that element. And you'll recall that the atomic number is always equal to the number of protons that that element has in its atoms. Similarly, there's a smaller number, or a number in smaller type, that exists in the bottom of the box, typically down here, that has many digits to it. And that number typically represents the mass of that particular atom, the atomic mass. And as you'll recall, both the protons and the neutrons have a mass of 1, so the mass of an element's atoms is always going to equal the protons plus the neutrons. Add those together and you will get the atomic mass. The atomic number is just the number of protons. Okay, let's go back to our model of the atom, where we have our electrons orbiting around the nucleus. As we said, these electrons will orbit in different energy levels or orbitals, and the number of electrons that are in its outermost orbital is referred to as the valence electrons. This is a very important term to understand. Valence electrons is simply the number of electrons in the atom's outer level, or outer orbital. Simply the number of electrons in that outer orbital. So, if in this case this atom here has 8 electrons in its outermost shell, its valence number would be 8. If the atom had 4 electrons in that outermost orbital, its valence electrons would be 4. It's simply the number of electrons in the outermost shell of an atom. Now, the other term that is very important to remember is an element's oxidation number. Oxidation number is different from a valence number. Related to it, but different. We said that typically the energy or orbitals of electrons, I'll erase this, exist in these levels where the first orbital or level can hold only 2 electrons, the second orbital or level can hold up to 8. Well, let's assume that that second orbital has 6 electrons. And this actually would represent the element oxygen. Oxygen has 8 electrons, 2 of which are in the first shell, and that completely fills up that first shell, and the remaining 6 are in the outer shell, giving it a total of 8. So, its valence number would have to be 6, since it has 6 electrons in its outer shell. But its oxidation number, in this particular case, is 2. Now, where does the 2 come from? Recall that the second outer level of electrons in an atom can hold up to 8. But oxygen only has 6. So it has room for 2 more. The number of electrons it takes to fill up the outermost shell would be the oxidation number. Now, in some cases, an element may have only 2 electrons in its outer shell. What happens now? Would its oxidation number be 6 because it needs 6 more to fill it up? Actually, no. In this atom, the element would rather give up the 2 that it already has in that outer shell rather than gain 6 more, because gaining 6 would be more difficult. And atoms are kind of lazy. So they'd rather give up the 2 that it has than gain 6 more. Well, if it gives up the 2, then its outermost shell then would be full, because it has 2 and it's full with 2. So its oxidation number in this case would also be 2, but because it gave up 2 electrons rather than gaining 2, we would call it 2 plus, because it gave up 2 negative charges. In the first example, where oxygen gained 2 electrons to fill that outer shell, it actually gained 2 negative charges, so its oxidation number would be 2 minus. So simply put, the oxidation number is the number of electrons that an element will gain or lose to have a full outermost shell of electrons. In our next lesson, we'll talk more about the periodic table. Until then, have a good day.